thank you again for everyone who is here today with us. So just a small reintroduction of the next step we are going to make for the camp. So right now we are actually in the second live online meeting. The third one, I just want to remember you all, is on the 15th of April, and it will be the last one for all the people who wants to ask questions to our teachers. So please feel free to ask them online in the YouTube channel or in the forum I shared with you in the email. And on the 30th of April, we'll have the deadline for the courses. I just remember you that the courses are 9. So please check the link in the Academy. And on the 3rd of May, you will have notification for the Datathon admission. So just to remind you all, nothing else. And I wanted to thank you all for this first part of the camp. As you can see, we have many students who registered to the camp, and right now the active ones are about 314. Yes, 314. So we're very excited about it. 277 courses were done. So many of you actually completed the courses, and 6 participants already finished them all. So very glad about it. And I also wanted to let you all know that we are actually reading all the feedbacks you are giving us in the courses. And of course, we will try to make them better for maybe the next session of the camp, and hopefully also for this session as well. But as you know, we will need some time to adjust them all. So please be kind to us. And first of all, I would like to introduce you the first professor of today, that is Roberta Savella. Please, Roberta, you want to say something?
Hello, everybody, and thank you, Sara and Valerio, for the invitation for today's meeting. I am Roberta Savella, and I co-created the LED course, so the course on legal and ethical aspect of data science. So today I'm here to talk a little bit about it and the reasons behind this course, which I think it is very important to highlight that at first was entitled in a very different way. The first title of the course was First Aid for Responsible Data Scientists. And I think that captured the reasons behind this course, because as you know now very well, working in data science, it is all based on data. And it is very, very important to understand since the beginning of working with all this kind of information, the ethical and legal aspect behind the work that you are doing. Also to understand what you can do and what you cannot do, but also to understand the purposes and the problems that your activities would create, not only for yourself, but also for society. If we want to become responsible researchers, responsible data scientists, we need to understand all these implications. So in our course, we start with a little bit of an ethical consideration, and we really want the students to understand all these ethical implications of their activities. We also discuss some of the very important and famous cases that arose in the past. We make some examples, for example, of discriminations that derived from the not responsible dealing with data, and also of artificial intelligence systems. So we really wanted to make students understand the issues and the questions that they should ask themselves when they start to work with beginning. Anyway, as I was saying, the first reason behind the course was to create also awareness on these issues. And then there was another part of the course which was about data protection in general, to understand also the legal aspects of data protection. Of course, we don't expect data scientists to become legal scholars as well, but it is very important for them to at least know that there are some rules, so they can ask their friends who work in the legal department, for example, when they have any doubts. So that was the second part. And then we tried to give you a glimpse of the AI Act, the new European regulation on artificial intelligence. There's a common misconception that the AI Act does not apply to researchers, but this is not in fact true. As you will see if you follow the course, the AI Act does apply when you create artificial intelligence systems if you want them to use them for purposes that are different from pure research. For example, if you want to create a new application that will be used by professionals, for example, then you need to comply with the AI Act. So you need at least to understand a little bit what this regulation entails. And then there's a final part of the course, which is about data governance and also data altruism and the responsible reuse of data in research, because there are certain specific rules for that as well. And these are all mechanisms that you could actually use in your data science activity, also to gather data for your research. So it's very important to be aware that these mechanisms exist. And also there was a part about intellectual property, because when you write a paper, for example, when you create a new application, you are creating new intellectual property material covered by intellectual property. So you need to understand at least a little bit what this entails, and which are the kind of licenses, for example, that you can use. So these were the reasons behind the course and a little bit of an overview. I just want to highlight as well that in the current situation with new technologies and artificial intelligence systems and data science in general, it is more important than ever to have interdisciplinary perspective and to have a little bit of understanding also of things that go beyond your field. So you should really have a little bit of a glimpse to these other fields, even if you're not a legal scholar. And this way you can start from the beginning your research in a way that you are sure that will be ethical and compliant with the regulations, at least in the European Union. So this helps you as well. So your research does not just lead to a dead end, because at the end of all your work, then you discover that you could not in fact do that, or that you worked maybe for weeks or months on something, and then the result of your work could be used to harm society or a minority group. So it is very, very important for you to understand this from the beginning of your work and to integrate these considerations in your research activity. And also the questions in the course that we put in the reflection corner, for example, were just a way to make you reflect on these issues and to learn that sometimes you just need to ask yourself the right questions. There are not always answers to these questions. We are in a very confused situation at the moment with European regulations, but also in the entire world, because with these technologies are very new and we are still trying to regulate them and understand them. So it is possible that our questions don't really have an answer at the moment, but it is still fundamental to ask yourself these questions, to at least be aware that these questions are there. So I'm finished. Thank you.
Thank you, Roberta. It was a very nice introduction, and it's quite important right now to be aware of all these issues. So thank you again. Now I'm going to present Professor Roberto Pellungrini. Please go ahead.
Hi everyone, I'm Roberto Pellungrini from Scuola Normale Superiore, and I prepared the material for the course on explainable AI. And today I'm also representing Anna Monreale, which could not be here because of previous endeavors with the national PhD in artificial intelligence. So I'm also covering for the presentation of the course of databases, which I also helped in, let's say, preparing the material. So maybe let's start a little bit talking about databases, which is a more, let's say, introductory course, more basic course. I think that for anybody getting near, anywhere near data or machine learning in general, it's important to know, at least on a very basic level, how data can be stored and how data can be handled. So the database course provides a very, very basic introduction to the logical components and the theoretical backgrounds needed to understand how a database is actually built. So from how to structure ideas into relationships, then into tables, and turn a conceptual model of a database into a working logical relation model. And the course also covers some of the basics of SQL language, which is needed to query the database and extract the information that we need. And this is, let's say, the very first step of any data science pipeline or any machine learning pipeline, because again, getting hands on the data is the first thing that you need to do to actually build reliable machine learning models. So it's a very, again, basic course. It's needed, in my opinion, to have an understanding of how you can organize knowledge and how you can query data to actually also perform some of the basic analysis that are needed to understand the phenomena that is described by the data, which is, again, the first part that you need to do before even applying a machine learning model. You need to understand the phenomena that are described in the data, and this you can do by building a good database and querying it in an appropriate way. So again, this is the course that also Professor Anna Monreale, for example, teaches at the University of Pisa at undergraduate students, and is actually one of the very first starting course also in our master in big data analytics at the University of Pisa also. So I think it's a very nice starting step, let's say. And for the other course, the one which I was more directly involved, which is the course on explainable AI, that's a more, let's say, advanced course focused just specifically on those techniques that allow you to explain machine learning models that have a certain degree of opaqueness. In general, you can divide, let's say, split machine learning models into two big categories. Machine learning models that are interpretable by design, whose structure, let's say, is sufficiently clear and sufficiently simple to be understood by any human being, and deep machine learning models, black box machine learning models, which are models whose internal structure is too complicated to be directly interpretable by non-experts. Okay, and so explainable AI is essentially the study of all the techniques that are used to explain black box models. But not only that, also of those models that inject by design some level of interpretability into the structure of the model itself. So, for example, in the course, you've seen that we touch both the post-hoc explanations of black box models, but also interpretable models. For example, also concept-based models for images, where some degree of interpretability is baked into the structure of the network itself. So this is a course that has been developed, that I developed also thanks to Fosca Giannotti, which is she's a full professor here at Scuola Normale. And she holds a course on explainable AI for the PhD in artificial intelligence, and has developed, let's say, helped develop the research on explainable AI here in the PISA ecosystem, let's say, thanks to an ERC project that is the XI project, and some of the research, let's say, results of that project went also into the course. And it's a very hot and interesting topic, let's say, in machine learning research, especially because of also some of the things that Roberta mentioned before, especially the AI Act, where the right to have an explanation for automated decision subjecting real people, let's say, is a sanctioned right in the AI Act. So it's important to know which techniques we can use to uphold, in a sense, that those rights, and to make them practical. Okay.
Thank you so much, Roberto. Just a small in the camp, but you are all free to join it. Oh, I don't know if I'm online, actually.
You froze, Sarah.
Okay.
At least for me,
Yeah.
you're frozen. Okay, now you're
Okay, now
you're
I can
back on.
see everyone. Thank you so much. So it's a very interesting course, and it was one of the last course we published, so we are quite proud of it. And let's hope the feedback will also come from that, so we can improve all the courses too. So the next professor is Alina Sirbu. Oh, please, Alina.
Hi, everyone. So I'm Alina Sirbu. I used to teach the data analysis course at the master's degree, at the SoBigData Masters in big data. Now it's in AI, I think. This changed the name. So it's so many years ago that I can't even remember the name. So I helped prepare some of the materials for this course. The course is a very introductory course to data analysis. I think when we did it, I don't know if it's done anymore. I think so at the master. It's really like the first thing that people see. And the objective is to introduce complete beginners to data. Okay, so we start with really basic knowledge and concepts like what are features, what is tabular data, what is structured data, not structured data. Then we go a little bit through probability theory because in order to do data analysis properly, we need statistics, and in order to do statistics, we need probability theory. So there is a little bit of probability, a little bit of statistics. The course is in Python. Okay, so all the exercises, besides the theoretical background, all the exercises are done in Python, but also Python at the very beginner level. Okay, so no pandas, no scikit-learn. It's all very, let's say, old style Python. Okay, lists, NumPy, SciPy, all these packages. So really the idea is that if you haven't done data analysis, this is the first course that you should do. So there is a quite important part on descriptive statistics. Okay, so what are means, averages, and how to compute this from your data. And then the more advanced stuff, inferential statistics. So there is a lecture on hypothesis testing, trying to understand what is a p-value and how we can prove that things are different in two different samples. And I think this is, I mean, obviously a statistics course wouldn't be possible because a statistics course can be a whole year. So we've tried to extract the, let's say, main concepts that are necessary in order to start doing data analysis. We also talk about estimating means, interval estimates, confidence intervals, and so on. And again, we do everything in Python. So there are like code examples and then a lot of exercises on how we can compute this in Python. So all of this is diagnostic analysis. Okay, if we think of the traditional way of talking about data analysis, diagnostic analysis tells no, descriptive analysis tells me what is going on. Okay, so I'm looking at the process, I have my data, I want to understand what is going on, so I do descriptive analysis. The diagnostic analysis that I confused comes after when I try to understand why things are happening. Okay, so I'm trying to look at relations between variables, and now we're going into correlation, we're going into regression, but regression from a statistics point of view, and not so much as a predictor. Okay, so not so much as a machine learning concept. So also hypothesis testing falls into the diagnostic analysis. So we, let's say, look at these two main blocks, descriptive analysis, diagnostic analysis, and try to give the very basic tools necessary to be able to do it. I would say that this course needs you to know a little bit of Python. So you could do it in parallel with the Python course, or you could start first the Python course, and then once you're okay with working with array lists, NumPy arrays, then you can start this course. You need some math knowledge, okay? But statistics, I mean, we try to introduce all the concepts more or less slowly, so that, and intuitively, okay, with not a lot of mathematics behind, as little as possible. And I would say that it can be a base for the more advanced courses in data mining, machine learning, explainable AI, and so on. So I would put it there, like first Python, then this. And it can be very easy if you already did some data analysis. You can find it very easy. If not, it can be useful to clarify some aspects. So I think I've said everything. I don't know if I was too fast, maybe.
Don't worry. Thank you, Alina. Actually, I was, as a learning designer, I have these courses now, and with so many feedbacks, I'm trying to analyze them.
Mm-hmm.
And I can see again that data analysis for me was a very important course to take. So luckily,
Okay.
I have also that kind of course. Of course, in the other
Just
environments.
To give an idea of the, let's say, the concepts that we're talking about, now we're using Python, but in the first editions, like early, like in the old times, we used to use Excel to do the exercises. Okay, so Python was not even necessary. But then I mean, it's clear that Excel is a very powerful tool, but Python, it's a skill that we cannot avoid. So because we wanted to do this course before the Python course, but then we understood that it's better to do first a little bit of Python than this, so that it can be more rounded course. Okay.
True. And also, we have many students from very different fields. We have students from nutrition, students from mathematics, but also from political sciences. And I can really see that all these aspects of life, because actually university prepare for life, an aspect of it, of course, really have data analysis inside. You need to analyze data for having some output and some kind of understanding of the reality. So that was quite important. Thank you so much.
Thank you.
So our last professor from today is Giulio Rossetti, that I'm going to leave the spot to you. Thank you, Giulio.
Thank you, Sarah. So first thing first, I have to give credit to the, let's say, to the one that designed the course, because I'm not the one that designed the social network analysis course, the complex network course, but is a researcher from ATH Zurich, the former researcher from the ATH Zurich. I think they changed affiliation, which is Viva. And so basically I would talk about this course because I teach a similar course here in Pisa. I think already it's been 10 years I'm teaching this course. I'm a senior researcher at the Italian National Research Council, and the course Complex Network Analysis that you will find on the Academy is basically a gentle introduction to this field of research. It is exactly network science. That is a particular, let's say, field because it is really multidisciplinary, because it embeds several, let's say, research disciplines, from graph theory to application in social network, in sociology, technological network, brain network, and so on and so forth. So basically, the assumption is that this course will help you to understand how to model specific reality through networks and use this network to extract knowledge. So as already mentioned, it is a very introductive course where you will learn what is a graph, basically. So how to model entities and relationships among them, and how to use this model in order to measure things, to measure, for instance, centrality index, to understand which are nodes that are more connected, more important for a given context. So, for instance, in a social network, to understand which are the influencers, or which are, for instance, I don't know, the spreader in a context in which we are studying an epidemiological setting or an opinion dynamic setting. And then you will move through different kind of other information, like how to analyze global measures like the degree distribution, or to measure the density of a network, to understand how connected are different parts of the graph, or how, let's say, homogeneous are different parts of the graph with respect to a given attribute. So if there are some rules that are, let's say, connected to how the network evolved through time in terms of the homogeneity, the homophily of the users or the elements that compose the network that connects to each other, let's say. In the course, you will also see how to compute communities. So how to break the network into components that can be analyzed independently because they probably have some meaning for the system you are analyzing. For instance, I don't know, studying in social setting, data from a social network, you will see that extracting community can help you identify semantical space like, I don't know, echo chambers, or coherent, let's say, community of individuals sharing a specific kind of environment. I don't know, extracting from a network built on Facebook, you can identify a network composed by geographical individuals that share the same physical spaces, or identify individuals that, let's say, belong to the same institution or to the same university or something like that, let's say. So you can annotate this kind of structure in order to identify different stuff. Another thing that you will see in the course is how network evolves. So you will see that network complex systems are not static in time. So nodes and edges can appear and disappear, and how to model them is important because the different kind of modeling will allow to do different kind of inference in your system. And similarly, you will see also that different process can diffuse over a network. An epidemic, as you already mentioned, an epidemic process. So you will see very simple example of this kind of, let's say, topics that all of them could take, let's say, hours to be discussed. You will see that this course has a more or less a duration of 2 hours with exercise and something also in Python. But consider that the classical course often took 40, 50 hours to be completed. So let's say it's a really, really succinct collection of topics that should allow you to navigate, let's say, complex network analysis in different domains. Apart from that, I would say that the course is very well, let's say, devised in order to provide you not only the theoretical knowledge, but also hands-on with Python to analyze this kind of data. So you will see prevalently a library in Python, which is NetworkX, that is a very simple library with a very simple, let's say, learning phase that will allow you to load data from any domain, model them as a graph, and then try to apply different measures to get the category of what is happening. And to compare also your results with synthetic network that will basically provide some basic let's say, default scenario to compare with. So to understand if your network tells you something that synthetic data already prevented to show or not. So it's a very simple course that is quite detached from the others. It's more, let's say, a data model specific course. So if your data can be modeled with a network, then you can use this course to learn how. But it's something that, let's say, has a prerequisite all the data analysis part or the data understanding part that you can do in a data mining, the machine learning course, as you already discussed. So I would say this is more or less everything that I can tell you about this course. And if you have any questions, I'm here.
Thank you so much, Giulio. Right now, we already have 12 students that finished the complex network analysis course. And we have some feedback that weren't bad. So actually, they were quite good. So let's hope it's going to be easy because, yes, it's a complex course in other aspects. So I hope everyone will understand everything. And in case, I hope I'm not going to disturb you a lot, but I'm going to ask you questions from them too. So first of all, thank you all professors for this meeting and for giving me the time and us the time to ask questions and answer to this introduction of the course, because some students were quite confused about how can we start, where do we start, and why why these courses. But we can see that everything is attached to each other, and data analysis in total is quite complex itself. So we need to understand as much as possible, since we are in a society where everywhere is data, and from every social network we take data, analyze them, and it's very important to know about it as a civilian first, and then also as a data analysis. So, oh, I think we actually have Anna Monreale. Hello, Anna. Thank you
Hello,
for giving us the
everybody.
time. Please present
And
yourself.
thanks, Roberto, for substituting me in this introduction to the database, but I was in a PhD committee while you are doing the presentation. Thanks. Thanks so much.
Thank you. It's a pleasure to have you too. And I hope the meeting wasn't too long. But so we have very, very small questions from for all of you. First of all, a practical one. As teachers, what are the first and the most basic errors you can see in your students? We have students that are alone and don't know where to start actually. So what are some recommendations you can give to them to start being able to analyze data, to understand what to take from data, etc.? So please, if I don't know if Roberta wants to start, or some of you have some questions to give us, please.
If you want, I can start, because
Yes, please.
I will share my experience when learning something new, and which I always tell also to my son. The first time I start to do something new, the first reaction is panic. Okay, because I open the book and I'm like, oh my God, every time I read something, there is much more, like it all bifurcates, okay? It all multiplies. Every time I read something new, there is so much more that there is around it, okay? So panic is the first reaction. So don't worry, it's normal, okay? Just go through it and then sleep over, sleep it over, and then the next day start reading, and then you'll see that things clarify as you go ahead. Okay, so the more you go ahead, you may need to read things twice, but you start to realize how things are organized, you start to see things, and then you you understand what's going on, and you see that you move to the next level where it's not panic anymore. It's like, okay, I can see the end of the tunnel. And then once you've finished the book or whatever the course, you will see how things connect. So this is the first suggestion that I have. The second one, I think many of the courses are very hands-on. Okay, so I think that when learning, I mean, in all the courses, we need to program one language or another, be it SQL, be it Python, be it what it is. Learning how to program can only happen if you program. Okay, reading examples, reading through all of the examples and studying is not working. Okay, I tell my first year undergraduate students who don't know how to program, I say, for this course, you don't need to study. If you study, it doesn't work. Okay, you need to, of course, it's a joke, you need to study, but you need to just do hands-on work, do many exercises. And the more exercises you do, then things just come. Okay, so just trust us, things just come. Do so many exercises and don't panic. Those are my two suggestions.
Thank you. They're so true, actually.
Can I add something, another dimension? So the panic sometimes derive from the fact that you are from a completely different background. And so the first step that you need to do is to acquire the language that sometimes is completely different. So because you need to be, let me say, aware about some concepts that sometimes as a computer scientist, we call the same thing in a different way with respect to another person coming from a different background. So in my life, in my career, I had a lot of opportunity to talk, for example, with the legal experts, and where we are discussing, we realize that we call the same thing in a completely different way. And this is something that can generate panic because while you are studying, you need also to understand the concepts and to acquire the language, to acquire the let me say, the meaning of the stuff. And so this is something that you need also to address during the study. So the panic, in my opinion, during the first part, also during the first courses, is normal. And but as Alina suggested, you need to try to manage this and also take your time. So, in the sense that, okay, you are doing a module with some concepts. Before passing to the second module, sometimes it is necessary to also take time for to make more concrete what you read, what you learn, because sometimes the results arrives slowly initially, and then they you are able to consolidate faster in the next module. Also during in the same let me say learning activities. So for example, in database, first of all, for example, if you understood something, you are understanding something about simple queries, consolidate the simple queries and then go let me say, in complicating something. Because if you are not so strong in solving simple query, complicating the stuff doesn't work. Okay, so it's better that you take your time and for for understanding if you can go after step by step. So only for completing the suggestion from Alina.
Yeah. Actually, many students asked for more exercises, more hands-on, because practicing is very important. And I know the courses can't really cover all the practices needed, but hopefully also in SoBigData Research Infrastructure Gateway, you can see the link also in the Academy. You have a whole environment like Jupyter Notebook and data sets, methods to practice with them. And of course, we have wonderful teachers who can answer your questions, because I know you can have many as a student. I was a student myself, and from psychological and pedagogical background, I started with like basic programming, and then data mining and machine learning, and it was another language. Honestly, I was lucky. I had very, very good friends around me, and they were so much help. So if you have a community inside the academy, but also us from emails and calls, whatever, we can be of help, and we will be very happy to do that. So I actually can't see any questions, except maybe the fact that okay, where can I have more practical example? Also, I read a feedback few days ago in which from legal and ethical aspects course, they ask for more examples, like practical, realistic example of legal cases in which something like that happened. I didn't know what to answer, but if Roberta has some more examples, please.
Well, I mean, I wanted to add something also to what my colleagues said before, because in my case, of course, it is a different thing. We don't have exercises, we don't really have programming, and the main thing is that the students should understand, in my opinion, is that they have to learn to ask themselves questions, ethical questions, legal questions, when they deal with data. This is the first thing. For the more legal, strictly legal perspective, I have a legal background, so that's my area of expertise. I would suggest you not to try to remember everything. It is impossible. No lawyer remembers everything. But it is the first thing you have to do is to understand where to look when you have a legal issue. So try to map the places, the specific regulations in which you can find your answers. For example, the first thing that I say when I teach data protection courses, Article 4 of the GDPR gives you a lot of definitions on data protection concepts. So this is where I always tell my students, go and look to Article 4 when you have a doubt, for example, about what is consent, what is personal data, who is the data controller. First of all, go and look at Article 4 of the GDPR. So this is my first suggestion when we are approaching the GDPR. I mean, when you deal with these things, also try to actually read the regulations. You find them online. You also find some very nice websites. For example, for the AI Act, there's one I always use, which is called the AI Act Explorer, where you can find the AI Act just article by article. You can select them, you can look at the index, you can look at the annexes, at the recitals. It is very, very helpful to just navigate the regulation. And you can find something like that for the GDPR as well and for other relevant regulations. But first of all, just go and have a look and actually read it. So sometimes you can find your answers there. As for the examples, I mean, at the moment it is impossible for me because you didn't give me a case. I mean, this is also another thing. When you deal with the legal and ethical issues, you have to look at the actual case. You have to see all the circumstances of the case, because most of the times the answer will be different depending on the circumstances, and also depending on the timing, and also depending on the place in which you are, because we are dealing a lot with European regulations. So, I mean, this is where we are based, but there are a lot of other places in the world, and also in the European Union. Some things are not the same whether you are in Italy or in Poland or in Ireland, for example. So it always depends case by case. You find a lot of articles online about case law. I mean, so sometimes there are news about, for example, issues with AI systems, problems with chatbots, for example, the way in which they were used. For example, there were a lot of cases, mostly a few years ago when ChatGPT came out, about lawyers using ChatGPT just to fabricate their documents to present to the judge, and then the judge realized that ChatGPT invented many precedents, and the lawyer just defended themselves, saying, "I thought it was a search engine." So I thought that the answer the ChatGPT gave me was true, and I asked the ChatGPT, "Is this correct?" And ChatGPT said yes, so I was fine. I mean, there were a lot of news articles about these things. So these are actual examples, for example, of unethical use of these systems, but mainly just from ignorance, because people didn't even know what they were using and the reasons for these systems to be used at all. So this is probably the closest thing that I can give you to of an example right now. But yeah, I mean, look at the circumstances.
Yes, actually, it was a general feedback of the course, because they saw many articles and many topics of ethical and legal aspects, and they were maybe amazed by the complicated things and the many unethical and ethical examples. But
the other thing is, you're not a lawyer, so you have to understand that these things are there, that these issues are there, and that there are rules. But when you're in doubt, always ask a lawyer. This is like the first thing to do. You cannot solve these things alone, especially because it depends on the case. This is the most common answer used by legal scholars. So you have to know that these rules are there, you have to know that these issues are there, and that you have to ask yourself these questions, but then always team up with a lawyer or a legal scholar at least.
True. Or ask the explorer the tools that you show us, that you told us before. But I don't remember quite well. I'm very ignorant by those facts. So just for saying again, thank you all for enjoying, for coming to this meeting and joining us. And I think we don't have any more questions, so I will leave you free. And thank you again, all the teachers and the students who participated in it. I hope you enjoyed it. And if you have questions, please ask them online, on emails, or in the forum. And we have another, the last online meeting for the camp that is on the 15th of April. So I'm going to again share with you the YouTube link for the students to joining us on the 15th. So thank you again, and I'll say bye-bye to everyone.
Thank you. Bye.
Thank you.
Oh.
Goodbye.
Thank you. Bye.
You, bye-bye.
Bye-bye.
Bye-bye, thank you.
Ecco fatto.
Fatto?
Vai.
Posso